Good day everyone, I am James Andrelang and today I will be representing a comprehensive discussion on Article 7.70 Optical Fiber Cables and Raceways from the Philippine Electrical Code. This presentation focuses on the rules, standards, and safety requirements for installing optical fiber cables inside and outside buildings. Although optical fiber systems do not carry electrical current in the same way as power conductors, improper installations can still pose risks such as fire spread, mechanical damage, and signal interference. This slide introduces the foundation of Article 7.70, the Fine Print Note, or FPN. Clarifies that the article addresses installation requirements, only it does not cover the internal manufacturing standards or construction of optical fiber cables themselves. This distinction is important because installation professionals must follow PEC rules, while manufacturers follow separate standards. The scope explains that the article applies to both optical fiber cables and raceways, ensuring safety when they are roughed through buildings, structures, or connected spaces. Also, presents essential definitions. For example, an abandoned optical fiber cable is a cable left inactive and not terminated in any equipment. Such cables can increase fire load inside ceilings and walls. Another key term is cable sheath, which refers to the outer covering that protects the optical fiber standards for environmental and mechanical damage. Optical fiber cables are unique because they do not carry electrical current, but they can still be installed in areas where electrical hazard exists. The article specifically addressed the rules for installing fiber in hazardous locations, such as areas with flammable vapors, gases, and combustible dust. To ensure safety, any installations in these areas must follow strict sealing or protection. Requirements to prevent ignition or the spread of hazardous material through cable openings. This conduct create potential hazards due to the concentration of flammable substances, so fiber cables must be installed carefully and in compliance with manufacturer instructions. The article discusses composite cables, which include both optical fibers and electrical conductors within the same jacket. When these cables are used, the electrical conductors must follow all applicable rules from other PEC, particularly regarding grounding, insulation, and conductor protection. This clarifies that optical fiber cables can be installed in hazardous locations as long as they comply with specific sealing requirements. It highlights that cables placed in areas with dust, vapors, or loose stock must meet wiring system rules for safety. Composite optical fiber cables, those containing both optical and electrical conductors, must follow the standards for each type of conductor they contain. This ensures safe and appropriate usage of cables in environments with increased risk. To ensure safety, any installation in these areas must follow strict sealing or protection requirements to prevent ignition or the spread of hazardous material through cable openings. When these cables are used, the electrical conductors must follow all applicable rules from other PEC. This slide focuses on two major concepts: ensuring access to equip and maintaining a high-quality installation standard. First, the article requires that fiber cables can be installed in a manner that does not block or restrict access to electrical equipment, such as circuit breaker, switchboards, or control panels. Clear working space ensures that technicians can safely perform maintenance or emergency operations without interference from communication cables. Second, the PEC emphasized the importance of performing installations in a neat and work-like manner. This means that all cables must be well organized, properly supported, and free from unnecessary strain. The article requires installers to use straps, staples, hangers, or cable ties that do not damage the cable jacket or fiber integrity. The slide also references fine print notes that remind installers to follow, which reinforce proper workmanship and fire safety practices. The overall message is that even though fiber cables do not carry high voltage, they must still be installed with precision, orderliness, or safety in mind. A clean, organized installation is not only aesthetically pleasing but also prevents long-term damage, reduces maintenance issues, and ensures system reliability. Abandoned cables are often left behind after upgrades or system changes, especially in buildings with long histories of renovations. However, the PEC requires that such cables be removed when they are no longer in use. The reason is that abandoned cables can significantly increase the fire load of a building plenum spaces, risers, and concealed areas. More cables mean more combustible material, which can worsen fire conditions and smoke production during an emergency. However, the PEC allows unused cables to remain if they are intended for future use, but they must be clearly tagged with a durable label. This label should indicate that the cable is not abandoned and may be utilized later. Without such labeling, inspectors may require the cable to remove to comply with code. The goal of this rule is to maintain safe, organized, and clutter-free pathways for communication systems. Removing abandoned cables also makes troubleshooting easier, reduces confusion during repairs, and ensure better airflow and fire control within ceiling spaces. The PEC requires that any penetrating opening, such as a hole or slot where fiber cables pass through fire-rated walls, floors, or ceilings, must be sealed using an approved fire-stopping material. These materials prevent flames, smoke, and hot gases from passing through the penetrating during a fire event. Without proper fire stopping, even a small cable opening can compromise the integrity of an entire fire-rated assembly. The code also notes that building structures may require a minimum separation between cable penetration or opposite sides of fire-rated wall. This separation helps maintain the effectiveness of the fire barrier. Fire safety is especially important in communication cable installations become optical fiber cables, through non-conductive, can still burn or melt, contributing to the spread of fire. Furthermore, plenum-rated and riser-rated cables must be installed according to their flame rating to prevent smoke spread in ventilation areas. The PEC states that fiber cables entering buildings from poles must be installed in a way that maintains safe distance from electrical power lines. First, they must be placed below power conductors to reduce the risk of accidental contact or induced voltage. Second, the cables cannot be attached to cross arms, which are designed exclusively for electrical power lines. Doing so could not create unsafe conditions or violate utility regulations. Installers must also maintain proper climbing space or poles. Climbing space is a vertical area from obstruction, allowing line works to climb the poles safely. Overhead fiber cables cannot intrude into this area. Another requirement is adequate separation from electrical service drops, as close proximity may lead to hazards during storms, line failures, or maintenance separations. Acceptable raceways types include IMC, RMC, PVC, and EMT. However, when using PVC or EMT, the cables cannot be installed in risers, plenums, decks, or environmental airspaces. This ensures that only properly rated materials are used in high-risk areas, particularly spaces needing in-hide fire protection. Proper grounding reduces electrical hazards caused by lightning or accidental contact with electrical conductors. It prevents dangerous voltage from appearing on non-current carrying metallic components. By following grounding rules, Installers ensure protection for equipment, building systems, and personnel. Grounding requirements for fiber optic cables exposed to contact with electrical conductors. If such cables enter or terminate outside buildings, their metallic members must either be grounded or interrupted using an insulating joint. This prevents electrical faults from traveling through the cable's metallic parts. Grounding or interruption must be located as close as possible to the point of entrance or termination. This minimizes the length of the potentially or energized material and reduces hazards such as induced electricity, equip damage, or shock risks. Bonding and grounding requirements found in 70.4.1. It outlines material sizing and installation conditions for bonding or grounding conductors. Conductors must be copper or corrosion resistant and have adequate current carrying capacity. Their length should be kept as short as possible and under 6 meters for dwellings to reduce voltage differences during lightning events. Conductors must also be physically protected when exposed to potential damage. Proper grounding practices that maintain system reliability and protect against electrical hazards. Proper grounding electrode options when installing fiber optic cables. It explains how to connect bonding conductors to intersystem bonding terminations. Grounding electrode systems or specific grounding points like metal water piping within specific distance. For structures lacking grounding means, options such as installing a ground rod are described. It prohibits using steam pipes or lighting system conductors as grounding electrodes. Grounding connections reduce potential differences between systems, improving safety and minimizing lightning-related risks. Bonding requirements when separate grounding electrodes are used. A bonding jumper must connect them to limit voltage differences. Exceptions exist only for mobile homes. It also introduced grounding rules specifically for mobile homes, ensuring metallic members of the fiber cables are grounded when no service equipped is nearby. Proper bonding protects the structure, equipment, and occupants by ensuring consistent grounding potential across systems. To prevent hazardous electrical imbalances and ensure fiber installations meet safety standards in mobile residential environments. The different grounding electrode options available when bonding metallic elements of fiber cable systems. The PEC provides several acceptable bonding locations to give installers flexibility depending on building layout and system design. One option is the intersystem bonding terminal, which is specifically designed for connecting communication and low voltage systems to the grounding network. Another option is connecting directly to the building grounding electrode system, which ensures a single, unified grounding point. The bonding conductor may also connect to a metal water pipe, but only within a certain distance from the point of entry to ensure proper grounding effectiveness. The service equipment enclosure is another permitted bonding point, allowing shared grounding with electrical supply equipment. In cases where none of these options are available, the PEC allows a separate grounding electrode such as a ground rod or plate to be installed specifically for bonding the fiber installation. This ensures that grounding requirements can still be met even in remote or unusual building configurations. Mobile homes present unique grounding challenges because they are often factory built, transported, and installed on site using different types of foundations. They may also use separate services equipment and disconnecting means located outside the structure. The PEC states that grounding requires depend on whether the mobile home has integral service equipment. If service equipment is present, the fiber system's metallic components must be bonded to the mobile home's grounding electrode system. If a disconnecting means are located remote from the home, grounding must follow the rules for connecting to the electrode associated with that equipment. Additionally, the grounding electrode must be bonded to the metal frame of the mobile home to create a equipotential bonding system. This prevents dangerous voltage differences during lightning strikes or electrical faults. Mobile homes often rely on flexible connections and may be subject to movement, moisture, or soil issues, making proper bonding even more critical. Without correct grounding, the metallic components of the fiber systems could not become energized, posing hazards to occupants and technicians. The raceways allowed for routing optical fiber cables within buildings. Fiber cables may be installed in a conduit or raceway that complies with Chapter 3 of the PEC, including ENT, EMT, IMC, RMC, PVC, and others. These raceways provide mechanical protection, help organize cabling, and support safe routing practices. However, raceway fill requirements only apply with optical fiber cables share a raceway with electrical power conductors. This is because heat dissipation and conductors crowding become issues only when power circuits are involved. Fiber cables alone do not generate heat, so raceway fill is less of a concern in fiber-only routes. Proper routing is essential for maintaining system reliability. Raceway must be installed according to the building's structural layout, avoiding sharp bends, pinch points, or stress that could damage fiber standards. Installers must also consider future expansion, ensuring pathways remain accessible and manageable. The OFN and OFC cables, the most basic general purpose fiber cables. They cannot be used in risers, plenums, or environmental airspaces. Flame tests ensure they do not spread far excessively. These cables are suitable for low-risk areas but must not be substituted in environments requiring higher fire protection. It reminds installers that cable type selection must match the installation environment to maintain compliance and safety. The requirements for circuit integrity (CI). Cables and fire-resistive cable systems. These cables must continue functioning for a minimum of 2 hours during fire conditions. They are used in critical communication systems such as emergency response, alarm circuits, and vital control signals. The PEC requires that CI cables or fire-resistive systems be listed based on fire endurance tests. These tests simulate real fire conditions, including exposure to flames, heat, and mechanical stress. Cables must remain functional despite insulation damage or external heat. In buildings, these cables are installed in dedicated fire-rated pathways, ensuring communication systems remain operationally long enough for safe evacuation and emergency response. The PEC requires that these assemblies meet all listing and marking requirements to ensure capability and safety. The outer jacket and internal fiber components must be properly identified. Incompatible jackets or improperly assembled strands can lead to signal loss, mechanical failure, or non-compliance with fire safety standards. Field assembly must follow manufacturer's instructions, including proper polishing, splicing, connectorization, and strain relief. Installers must ensure no contamination, improper bending, or misalignment occurs during assembly. Underground fiber cables entering buildings. It explains that while installed with electrical light, or power conductors. Separation must be ensured using barriers such as concrete or brick. Direct buried cables must maintain at least 300 mm separation from electrical conductors unless specific exceptions apply. These exceptions allow reduced separation when electrical conductors have added protections such as metal armor or raceways. The goal is to prevent electrical faults, interference, and hazards. Overall, the stress physical separation and proper conduit used to protect both fiber and electrical systems. The outlines requirements for assembling optical fiber cables in the field. Cables must be made from approved combinations of jackets and fibers and marked accordingly. Jackets must indicate authorized fiber types, and fibers must show markings identifying approved jackets. Empty jackets must meet communication raceway listing. Ensures that field assembled fiber cables maintain safety and performance standards equivalent to factory listed cables. Here's the table of the optical fiber cables. We have here the cable type OFNP, OFCP, OFNR, OFCR, OFNG, OFN, OFCG, and OFC. Permitted subscriptions: none, OFNP, 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 and OFCE. So that's all the optical fiber cables in buildings. This defines OFNP and OFCP plenum rated cables. These cables are suitable for installation in ducts, plenums, and environmental airspaces due to their fire resistant and low smoke properties. Our reference NFPA test defines acceptable flame, spread, and smoke production levels. This ensures that these cables meet strict safety standards for air handling spaces where fire hazards are high. The plenum cables are the highest fire resistance category in fiber optic installations. Circuit integrity (CI) cables, which must maintain functionality during fire conditions for critical circuits. CI cables must be installed in free air to maintain their rating. They must pass rigorous fire resistant tests such as ANSI UL 2196. CI cables are used in emergency systems where systems failure during a fire would be hazardous. The underscores the importance of following listing and installation rules to ensure cables maintain performance under extreme conditions. The OFN and OFC cables, the most basic general purpose fiber cables, they cannot be used in risers, plenums, or environmental airspaces. Flame test ensures they do not spread fire excessively. These cables are suitable for low-risk areas but must not be substituted in environments requiring higher fire protection. This reminds installers that cable types or selection must match the installation environment to maintain compliance and safety. Grounding devices. Where bonding or grounding is required, devices used to connect a shield, a sheath, or non-current carrying metallic members of a cable to a bonding conductor or grounding electrode conductor shall be listed or part of the list equipment. Table 7.76.1 Cable markings. So here in the table, here's on the left side cable marking, the type of the cables: OFNP, OFCP, OFNR, OFCR, OFNG,
OFCG, OFN, and OFC. On the right side is the type of the cable. Non-conductive optical fiber plenum cable is the OFNP, and conductive optical fiber plenum cable is the OFCR. Non-conductive optical fiber riser cable is the OFNR. Conductive optical fiber riser cable is the OFCR. Non-conductive optical fiber general purpose cable is the OFNG, and the conductive optical fiber general purpose cable is the OFCG, and non-conductive optical fiber general purposes cable is the OFN, and conductive optical fiber general purpose cable is the OFC. So that's all. Thank you.